Welcome to yet another solution video of May 2022. This one is Pure Math 3. In the first question, they are asking us to solve this equation, which is a combination of natural log and exponential. And let's do it. So let me copy the question first. I don't know if it is visible that well or not. E to the power 2x plus 3 equal to 2x plus ln 3. Okay, so now our aim is to find the value of x. So we'll first get rid of this ln. So this e to the power 2x plus 3 will be left out here, and the other side will become e to the power 2x plus ln 3. Since we have to separate this x and we have to isolate x's, so I have to separate these and this. So we can write e to the power 2x plus 3 equal to e to the power 2x and then multiplied by e to the power ln 3. Because the exponents are adding, the bases multiply. Okay, so e to the power 2x plus 3, and here they are inverse of each other, ln and exponential, they cancel out, so we are left with 3 e to the power 2x. Alright, now we can bring this e to the power 2x to the other side, so e to the power 2x minus 3 e to the power 2x equal to, I'll take the number to the right side, minus 3. The combination of these two will be minus 2 e to the power 2x because they are exactly same, only coefficients are different. This will be minus 3 here. Okay, we can cancel negatives on both sides. E to the power 2x becomes 3 over 2, and that gives us 2x equal to natural log 3 over 2 if we remove e from the other side, and x is half ln 3 over 2. Are they saying exact? No. They're saying us to give answer in 3 decimal places. So let me evaluate this. I'm getting 0.2027, and which we round off to 0.203. We are ready with the second question, which is solve this trigonometric equation between 0 to 360 should be the value of theta. Okay, so let me repeat the question again. 3 cos 2 theta equal to 3 cos theta plus 2. And this cos 2 theta can be rewritten as, there's an identity for it, 2 cos square theta minus 1 and equal to 3 cos theta plus 2. So let's open this and make a quadratic equation out of this. So 6 cos square theta minus 3 cos theta minus 2 equal to 0. These two also taken to the left side. So 6 cos square theta minus 3 cos theta minus 5 equal to 0. So now we have this quadratic equation. We can use our calculators to find the values of two causes. I can use quadratic formula for this. You can use your calculator also. So quadratic formula, minus 3 plus minus square root b square minus 4ac over 2a. So what do we get? 3 plus minus square root 9 plus 24 times 5, 120 over 12. So we have two solutions now. One is 3 plus square root 129 over 12. Second will be 3 minus square root 129 over 12. So if I solve this one, I get 1.196 approximately, and this one is negative 0.6964. Okay, we know that the cos theta cannot be more than 1, so this one is rejected, this is the one we will work on. It is a negative value of cos, and between 0 and 360, these are the quadrants where cos is negative. So let's find cos inverse 0.6964 to find our theta. If you notice, I have ignored negative because negative has given us quadrant, so we will not write it. We'll just write positive. If I put negative here, I will not get an answer I want. I want an acute angle. Alright, so when I use my calculator, I get approximately 45.9 and 45.9. That's what I will write here. So we have two answers now. First one, theta 1. We start from 0 degrees and go to the line created by the first quadrant, inside the first quadrant, which is 180 minus 45.9. That is 134.1. But we need three significant figures. Rather, they said that if the angles are in degrees, we can give answer up to one decimal place. So let's write 0.1 degrees. Second answer will be 180 plus, because it is going further to this line and it is crossing 180. So 180 plus 45.9, which is 225.9 degrees. We are ready with the next one also. The polynomial ax square plus x square plus bx plus 3 is denoted by this thing. It is given that it is divisible by 2x minus 1. That means it's a perfect root. So 2x minus 1 is a factor. Make it equal to 0, it becomes root. So 1 over 2 is the root. And when it is divided by x plus 2, remainder is 5. That means x plus 2 is not a factor. We get a remainder of 5. So if it was a root, we would make it equal to 0. So x is equal to minus 2 would be the root. But if we apply this, we'll get a remainder of 5. That's what they're saying. So let's substitute these roots into the equation to use remainder theorem. Okay, so ax cube. So ax cube, first root I'm using the proper root, 1 over 2, plus 1 over 2 square plus b 1 over 2 plus 3, and the remainder is 0 because it is a perfect root. So what do we get? A over 8 here plus 1 over 4 plus b over 2 plus 3 is 0. Let's get rid of the denominators by multiplying by 8, because 8 is the LCM of this particular equation. So what do we get? 8 will cancel out. So a 1 over 4 multiplied by 8 is 2. B times 8 will be 4b. Then 24 equal to 0. So we get an equation a plus 4b equal to 24 plus 2 is 26, but when they go to the other side, we get minus 26. This is equation number 1. Let's talk about the other one, which is not a root, but we'll substitute it similarly. A minus 2 cube plus not half. I have to undo this. Excitement. Okay. Minus 2 square plus b minus 2 plus 3 not equal to 0, it is equal to 5. The remainder is 5. Okay, minus 8a plus 4. This negative will become positive because of the square. Minus 2b plus 3 equal to 5. Minus 8a minus 2b plus 7 equal to 5, and if I bring this 7 to the right side, we get minus 8a minus 2b equal to 5 minus 7 minus 2. Let's divide whole equation by minus 2 because all of them are negative and all of them are even. So we get a simpler version of this. 4a plus b equal to 1. This is equation number 2. So now let's isolate b here. B equal to 1 minus 4a, so that I can substitute in equation number 1, and let me substitute here. So a plus 4 times b is 1 minus 4a now, equal to negative 26. So a plus 4 minus 16, a equal to minus 26. So a minus 16a is minus 15a. 4 goes and becomes minus 4 to the right side. We'll get minus 30 here. A equal to minus 30 over minus 15, positive 2. And b we have here, we'll use it. B equal to 1 minus 4 times a. V equal to 1 minus 8, which is negative 7. We got A and B both. Question number 4. The equation y of a particular function is given. It is given that the curve has one stationary point in the interval 0 to half pi. Okay, one, only one. Find the x coordinate of this stationary point, giving your answer correct to 3 significant figures. Okay, for stationary point, dy over dx have to be equal to 0. So we'll differentiate this. Dy over dx, since two parts are multiplying which both have a variable x, so we'll use product rule. So cos cube x, we will differentiate this one. We will not touch sin x. In second part, cos cube x will stay there and we will differentiate sin x. So sin x, square root of sin x can also be written as sin x to the power half. Just keep in mind while differentiating, this will be useful. So I'm going to differentiate this one first. So 3 cube will come in front and the exponent of cos will go down by 1, which becomes cos square now. And further, we have to differentiate the base, which is cos x. Differentiation of cos x is minus sin x. Okay, then we have square root sin x additional already, plus cos cube x stays cos cube x. Now this is here. So if I want to differentiate that, half will come in front and sin x, its power will go down by 1. So half minus 1 is negative half. And then we have to differentiate sin x as well, which is cos x. So now we have a little complicated part here, but we can simplify this by taking something common. So cos square is here, cos cube is here, so we can rather cos 4. Let's simplify, combine if we can combine things. 3 cos square x, and because of this negative, I will put negative in front, and sin x to the power, this is 1 and this is half. 1 plus half, 3 over 2, plus cos to the power 4x. These two give us cos to the power 4x, and half is in front, and sin x to the power minus half. So I was saying that we can factor this. So let's take the smaller of the two common, cos square, cos 4. So cos square comes as a common part. Sin to the power 3, 2, sin to the power minus half. Sin to the power minus half is, let's not write it here, right outside. This is common. Now what is left in here? Minus 3. Okay, then we have this is greater than this by how much? 3 by 2 minus half, which is adding here 2. So basically this will be sin square x when we take minus half common, because 3 over 2 minus half is square. So we can write square here. Alright, plus we have half, this one, cos to the power 4, cos square is also out, so cos square is left. And here sin x to the power minus half is already out, so no need to write it, we got it. Now, for stationary point, they're saying find the x coordinate of the stationary point dy over dx is equal to 0, because at every stationary point the tangent is a horizontal line, the gradient of horizontal line is 0, that's why dy over dx is 0. So that means this whole thing is equal to 0. That means individually cos square x will be equal to 0. This will also be 0. Sin x to the power minus half will be equal to 0. Then this minus 3 sin square x plus half cos square x will also be equal to 0. So let's look at them one by one. Square root both sides. Cos x equal to 0. So x equal to cos inverse 0. And the domain they said was from 0 to half pi. So let's draw the graph of cos for 0, 1 and minus 1. We should always draw the graph. That gives us good answer. So this is 0 here, it is 0 here. This angle itself is pi by 2. So this is 0. From 0 to pi by 2. Pi by 2 is the place where we have x equal to 0, but cos x equal to 0, but there is no equal sign here. If you see, there is no equal sign. That means we cannot count pi by 2. So no solution here. Let's talk about this one. It will be 1 over sin x to the power minus half equal to 0. To make this negative positive, I've reciprocated, and in no case a reciprocal can be 0. Whatever is the value of sin x, it can never give you a 0, because cross multiply also it will become 0. 1 is not equal to 0. This is also not giving us any stationary point. In our question itself, they said there's only one stationary point, yeah, and we have to find x coordinate of that. All right, this will give us, I think, 3 sin square x equal to minus half cos square x. This is how we can rearrange this. Divide both sides by cos square x. So cos square x gone here. This becomes minus 3 tan square x equal to negative half. Both are negative, so we can cancel negative signs. Tan square x equal to 3 multiplies with 2, cross multiply 1 over 6. Alright, that means we square root both. So tan x is plus and minus square root 1 over 6. Alright, odd kind of answer, but yeah, this is the answer. Now, from 0 to pi by 2, that means we have to just focus on the first quadrant, because this is 0, this is pi by 2, and in this quadrant tan is positive, that means negative is gone. We will not even look at negative. X is tan inverse square root 1 over 6, and in radians it gives us 0.387596, which can be rounded off to 0.388. Did they ask anything else or only the x coordinate? Find the x coordinate of the stationary point giving 3 significant figure. That is the value of x. Question number 5. By sketching a suitable pair of graphs, show that equation ln x equal to 3x minus x squared has one real root. Okay, in such case, what do? We make two equations of functions out of this. One is y equal to ln x, and second will be y equal to 3x minus x squared. This one is exponential, this one is quadratic. And then we draw them separately on the same graph. Okay, so let's draw y equal to ln x. It is a very fixed graph. It passes through 1 and starts from near to the y axis and goes like this. If you are not sure how to draw this, just make a table, give some values of x and y.
What will be the values of x and y? You can take hint from the next part. Next part they're saying the root lies between 2 and 2.8. So start from 0 or 1 or something and you'll get these kind of graph. Okay, if you have no idea how the graph looks like. All right. Second one is a quadratic. In this, I will first find the x-intercepts of this. For x-intercept, the y has to be equal to 0. So for x-intercept of quadratic, 0 equal to 3x minus x squared. So x taken common, 3 minus x equal to 0. That means the first x-intercept is 0, second is 3. So 0 and 2, 3. These are the two x-intercept. Since the leading coefficient of x square is negative, our graph for this will open down and these are the two x-intercepts and we can clearly see they are crossing at one point, so the root is 1. Only one root is there. That's what we've shown through the graph. Verify with calculations. The root lies between 2 and 2.8. For that, we should rearrange the equation by bringing everything to the left side. Now, root is between 2 and 2.8 we have to show. So first we'll substitute 2 in this and see what is the sign. So in place of x, I'm writing 2. So in this case, I'm getting minus 1.3068. When I substitute 2.8, I get 2.8 plus 2.8 square, and in this case 0.4696. Can you see? This is positive, this is negative. Change of sign indicates presence of root between 2 and 2.8. Part C, we have to use iterative formula, this one, to find the solution. So the starting point, because we know it is between 2 and 2.8, the root, we'll start with x1 equal to 2.4. So x1 plus 1, 2, yeah, will be square root. The iterative formula is given to us. I will substitute 2.4, the first thing here, and minus ln 2.4. And we will use calculator to find this, which will be 2.5149. And I'll continue this till I get my required solution. So I will just fasten up this video now. And we got our answer here. Because this iteration will give me, if I round off, 2.62. This is also giving me 2.62. So we keep on doing iteration till the time our required two digits are equal. So finally our root is 2.62 because of this.
Question 6. The variables x and y satisfy the differential equation, this one. When y is 0, x is 0, that the additional information they've given so that we can find some constant later. Solve the differential equation obtaining an expression for y in terms of x. To solve differential equation, first requirement is that dy and dx must be numerators. dy is already a numerator, so dx will go to the other side and become a numerator. Second requirement, the y should be with y and x should be with dx. So x is with dx, but y is not with dy. So let's break up this part first. So dy equal to x e to the power y over e to the power x. I can separate them. So now e to the power y is separated. And we'll bring that e to the power y to the left side. So let me write here 1 over e to the power y dy equal to x multiplied by 1 over e to the power x dx.
Both the requirements are fulfilled now. To solve the differential equation, now we should integrate both sides. So it is easy to integrate this one because it is equal to e to the power minus y, and the integration will be e to the power minus y divided by minus 1, right? But here we have one algebraic part, one exponential part that we have to integrate. And for that we need to use integration by parts. So in our list of by parts, we have one algebraic and one exponential. That means this will be u, this will be v prime. So algebraic x is our u and e to the power minus x is v prime. For what? We know that integration of u v prime, which is our question, prime is here, is equal to uv minus u prime v. So in place of this, we can write this. So let me do on the right side and then I'll come back to our main solution. So u is x, v is not known to us, but v prime is known to us. So v will be integration of v prime. So integration of e to the power minus x. And just like this part, we will integrate this as e to the power minus x over minus 1, which is minus e to the power minus x. All right, minus e to the power minus x minus u prime will be the differentiation of u, which is x for us. So it is just 1. V we just found out minus e to the power minus x dx. Okay, so minus x e to the power minus x, that's what we can write this one. And integration of minus e to the power minus x will be positive e to the power minus x by this method only. And because of this minus, that positive will again become negative. So minus e to the power minus x. Let's take minus e to the power minus x common, and we are left with what? X and plus 1. From this, I factored out e to the power minus x negative. All right, let's write it here. Minus e to the power minus x, x plus 1. So minus e to the power minus y equal to minus e to the power minus x, x plus 1 plus c. I forgot to write plus c here. All right, so negative and negative we can cancel out and we can write it as a denominator. So that it becomes, exponent becomes positive. So x plus 1 divided by e to the power x. This also becomes positive when it becomes a denominator. So now, reciprocate both sides. E to the power y equal to e to the power x over x plus 1. Next thing we should do, because they're saying we have to find y in terms of x, so just write y, remove e. When e is removed, we get other side as natural log. Now we can separate the numerator and denominator in natural log, or we can leave our answer like this. So what do they want? They're saying expression in terms of x. Okay, done. This you can leave your answer like this. We have a b part also. Find the value of y when x is equal to 1, and this is the format they want us to express it. All right. So let's write y equal to ln. Now x is 1, e to the power 1 over 1 plus 1. But the format has to be this way. So let's see, y equal to ln e over 2. So to change it to that format, we need to separate e and 2. So y equal to ln e minus ln 2, because they are dividing. When they separate, they subtract. So ln and e cancel out. That's 1 minus ln 2. So A is 1 in this format, B is 2. Moving on to the next question. Number 7. The equation of a curve is given. Show that dy over dx is this. So since x and y are combined here, we have to use implicit differentiation. Okay. So what should we do? We should differentiate them individually, but wherever we differentiate y, we have to add a suffix dy over dx. So x cubed differentiated as 3x square. Then we have 3x square y. X and y are multiplying, so we will use the product rule. 3x square prime times y plus 3x square and y is differentiated minus 3y square dy over dx because y has been differentiated and differentiation of 3 is 0. Okay, so 3x square plus differentiation of 3x square is 6x y plus 3x square differentiation of y will be just 1, but since it is y, we add dy over dx minus 3y square dy over dx equal to 0. So we'll keep dy over dx on the left side itself. So first we have 3x square, then we have minus 3y square equal to, this will come to the right side, minus 3x square minus 6xy2, and that's it. So let's divide both sides by 3x square minus 3y square. 3x square minus 3y square, they cancel out. Dy over dx is equal to, and let me take minus 3 common out of this, x square plus 3 taken, right? So 2xy. What is our target? Is it x square plus 2xy? Yes. Over 3x square minus y square. So this 3 and this 3 cancel, but we are left with minus 1 here. And to make it positive, let's multiply by minus 1 up and down, so that this minus 1 and this minus 1, they become positive. So dy over dx equal to x square plus 2xy over minus 1 will change the signs of these two. They will change their place, y square minus x square, and this was our target. And here is the B part. Find the coordinates of the points on the curve where tangent is parallel to x-axis. Parallel to x-axis, by that they mean that it's a stationary point. This is x-axis. Anything parallel to x-axis is a horizontal line. And if the tangent is horizontal line at any point, it's a stationary point. In other words, they're asking us to equate dy over dx equal to 0. So not directly they're saying, we have to take a reference from it and do this. So our dy or dx is known to us in first part, so we will do that one. So to x square plus 2xy over y square minus x square is equal to 0. When denominator multiplies with 0, it vanishes. We are just left with x square plus 2xy equal to 0. We can factor this. What can we factor? X. So we are left with x plus 2y equal to 0. Two parts are multiplying equal to 0. That means either x is 0 or x is equal to minus 2y. These are the two stationary points where the tangent is parallel to x-axis. So now, our equation was this: x cubed plus 3x square y minus y cube equal to 3. So they're saying find the coordinates. That means we have to find y coordinate also. right? So replace x equal to 0, we'll get the y coordinate. 0 cube plus 3 0 square y minus y cube equal to 3 0 0 y cube equal to minus 3 cube root. I hope you understand we can transfer this negative to the other side. So y becomes cube root of negative 3, which is negative 1.44 almost. So the first point where the tangent is parallel to x-axis is x equal to 0, y equal to negative 1.44. Now, this is going to challenge us a little. What will we do? We'll use the same equation again to find the x and y coordinates. So, x equal to minus 2y. So, in place of x, we will write minus 2y cube plus 3 minus 2y square minus y cube equal to 3. So, minus 8y cube, and this is 4 times 3, 12. 12y square and times y. There was y also, right? There was y. Minus y cube equal to 3. So what do we get here? Minus 8y cube plus 12y cube minus y cube, all of them cubes, equal to 3. And that is how much? Minus 9 plus 12 is 3. 3y cube equal to 3. Both cancel. Y cube equal to 1. And cube rooting both sides, y equal to 1. So we got y coordinate 1, which is not this. It is different from this. So we have to find x coordinate now. And again, we'll use the same equation. That equation is here. X equal to minus 2y. So x equal to minus 2 and y we got equal to 1. Yes, from here. So x equal to minus 2. So the second point, stationary point rather, is minus 2, 1. The first one was 0, minus 1.44. That's it.
Question number 8. In question number 8, they have given us a rational function and they're asking us to express it in partial fraction, and then B part we have to carry out this definite integral. Let's talk about the part A first. X squared plus 9x over 3x minus 1 x squared plus 3. This is our rational function. Let's assume that it is equal to a over 3x minus 1. Before we do this one, you should always ensure that the degree of numerator, which is 2 in this case, is less than degree of denominator, which is 3 in this case. This is 1 and this is 2, total 3. So we are good to go. Bx plus c and x squared plus 3 here. So now let's find the LCM of this one, which will be 3x minus 1 and x squared plus 3. And to merge these two, x squared plus 3 will multiply with the other numerator, which is xa, and bx plus c, the numerator of the second one, will multiply with 3x minus 1. Now, both of them have same denominator, we can ignore. Especially, what do we get here? X squared plus 9x, which was this numerator, equal to the numerator here, which is ax squared plus 3 plus bx plus c, 3x minus 1. Now, to solve this, our endeavor should be that one of the brackets becomes 0, and this can be made 0 if we let x equal to 1 over 3. So 3 times 1 over 3 will be 1, and 1 minus 1 is 0. This whole thing is useless with x equal to 1 over 3. So let's write here 1 over 3 square plus 9 times 1 over 3 equal to a 1 over 3 square plus 3. 1 over 3 square is 1 over 9, and this 3 and this 9 cancel, we will plus 3 equal to a Here also 1 over 9 plus 3. So can we divide it by 1 over 9 plus 3 so that both of them get cancelled out? This cancels, this cancels. That leaves a equal to 1, not 0, 1. When something is cancelled by dividing or multiplying, we write 1. Okay, what about b and c? Let's compare now. There's no other chance. This x square plus 3 cannot be 0, so we can't make anything else 0. So let's compare constants. So constant on the left side is nothing. Both of them are x, so there is nothing on the left side, 0. Here, a times 3 will be a constant. So we'll write 3a. Here, c times minus 1 will be a constant. So minus c. That's it. A is known to us, which is 1. So 0 equal to 3 times 1 minus c. Let's bring c to the left side. C equal to 3. Now to find b, we can compare coefficients of x square or x. I'm comparing coefficients of x square. Alright. So on left side, what is coefficient of x square? 1. On right side, a x square. This will be 1. I'm not writing x square on both, okay? Bx times 3x will also give us x square. So bx times 3x will be 3b x square. Again, no x square because I am comparing coefficients only. So 1 equal to a, this is a is 1 plus 3b. Let's bring this 1 to the left side. 1 minus 1 equal to 3b. 0 equal to 3b, that is b is also 0. Alright, so finally our partial fraction becomes a over 3x minus 1, right? So a is 1, that becomes 1 over 3x minus 1. B is 0, so we will not write it, we will just write c, and c was 3. Positive, yes, x square plus 3. That is our partial fraction. Now, in second part, they were saying, hence, find the integration of this function from 1 to 3 and simplified exact form. Okay, so let's try to do this. All right. So we have to integrate from 1 to 3, 3x minus 1 dx plus, let's keep 3 outside, 1 to 3, 1 over x square plus 3 dx. This is the second part, okay, b part. All right, so the integration of this is simple. It will be natural log of, let's put a absolute sign here, 3x minus 1. Okay, and what about this one? Plus 3. Now it is in the format of 1 over a perfect square time plus square root 3 square, a perfect square plus a perfect square. Whenever it is not there, though it is not a perfect square, I've just made it up. So its integration in straightforward way will be 1, rather this 3 already, right? So 3 over square root 3, because of this, tan inverse x over square root 3. This is what we have learned in our classes. If you don't understand how I got this, let me do it here hurriedly. Our integration was 1 over x square plus 3, right? So what we do, let's assume x equal to square root 3 tan theta. So dx over d theta will be square root 3 secant square theta, correct? So dx equal to square root 3 secant square theta d theta, and we can square this also. X square equal to square of this, which is 3, square of this, which is tan square theta. So now we'll substitute, it was dx also here. Let's substitute everything here. So 1 over x square, 3 tan square, 3 tan square theta plus 3, and dx is square root 3 secant square theta d theta. All right. So now it becomes 3 can be taken common from these two. So it becomes 1 over, let's write 3, square root 3 also here. This is square root 3. I'm writing outside. The 3 I took from these two, I'm writing outside. So we're left with tan square theta plus 1. And on top we have secant square theta d theta left. Tan square theta plus 1 is exactly equal to secant square theta, so they cancel out. This will also cancel out. So we'll be left with 1 over square root 3 d theta. That's it. And what is d theta? Integration of d theta? Theta plus c. And what is theta? From this particular assumption, theta will be tan square x over square root 3. So that's why I got square root 3 here. This was 1, right? So this is our integration from 1 to 3, and let me substitute the values 3 and 1 into this now. Okay. First of all, let's cancel out this one and this one. This becomes square root 3 when cancels out with this. So we are left with len 3 times 3, 9 minus 1, 8. So there is no need to write absolute anymore because it's positive. Plus square root 3 tan inverse x over square root 3, 3 over square root 3 plus c minus, we have to substitute 1 now, len 3 times 1 is 3 minus 1, which is 2. Okay, plus square root 3 tan inverse 1 over square root 3 plus c. C is cancelled first. Now let's open len 8 plus square root 3, 3 over tan inverse 3 over square root 3 is square root 3, so pi by 3. Now minus len 2, then minus, because of this minus, this will also become minus square root 3. Tan inverse 1 over square root 3 is pi by 6. So this len and this len can be made 1 len 8 divided by 2. Yeah, because they are subtracting. And I'm not going to cancel this out because otherwise the denominator will become a square root, which is not allowed. So let's multiply this by 2 so that we get a 6, right? Plus 6. So to make this 6, I have to multiply this by 2 square root 3 pi. We have to multiply 2 here. I'm doing it all this mentally. Please, you can try your calculator if you're not sure how I'm doing this. This is what I got. So 8 over 2 len 4. This is the final answer I'm seeing here. 2 square root 3 pi and square root 3 pi. Square root 3 pi is left by 6. And that's it. This is the final answer. Question number 9 is a vector question. In this question, they have given two lines L and M. This is L, this is M, respectively, and they have A and B constants in them. Okay, greatest given that the L and M are intersecting, they intersect. Okay, they intersect like this. Show that 2b minus a is equal to 4. Okay, so let's assume that the point of intersection is x, y, and z. So let's convert the two vector equations given into parametric equation, and since this point, let's call it M. This point is common between the two lines. Their x, y, z coordinates will be same at this point. So what about the first one? Minus 1. Then we have 2 lambda, right? 2 and lambda plus 2 lambda will be equal to, from the second line, 5 plus a mu. All right. Similarly, the y coordinate will be 3 minus lambda which will be equal to 4 plus b mu from the second line, and z will be 4 minus lambda equal to 3 plus mu. Since z coordinate does not have any a or b, so let's isolate mu in this one. So let's keep mu here and bring 3 to the left side. It becomes 4 minus lambda minus 3. So mu is basically 1 minus lambda. Now, since we've got the relationship between mu and lambda, let's substitute this relationship into the other part. Okay, so let's choose x1 first, this one. So minus 1 plus 2 lambda, which was on this side, equal to 5 plus a, and now mu has a value 1 minus lambda. So what is let's continue to take a on one side. Let's isolate this one. So 5 will go first. So minus 1 minus 5 plus 2 lambda equal to a1 minus lambda, and divide both sides by 1 minus lambda. What is left here? Minus 6 plus 2 lambda over 1 minus lambda equal to a. We got a in terms of lambda. Similarly, we'll get b also from the second set of equation. 3 minus lambda equal to 4 plus b, and mu is 1 minus lambda. Just like the previous one, we isolated a, we will isolate b in this case. So 4 goes to the left side first, and we are left with this b, and divide by 1 minus lambda, divide by 1 minus lambda. So b comes out to be 3 minus 4 minus 1. Minus 1 minus lambda over 1 minus lambda. Please never cancel this out. They are totally different. Here minus 1 has minus, here 1 does not have minus. So this is b. Now we have to show that 2b minus a equal to 4. So 2 and b is this, minus 1 minus lambda over 1 minus lambda, rather not equal to, minus a. A is this, minus 6 plus 2 lambda over 1 minus lambda, and equal to 4. This is what we have to show. So since both of them have same denominator, we can write this denominator as 1 and multiply the 2 with only numerator. That's what we do, like this. If I multiply 2 times 3/5, we don't multiply 2 with 5, only with 3. So it will be 6/5, right? Similarly here, 2 times minus 1 will be minus 2 lambda plus 6 minus 2 lambda. So it has to be equal to 4. Okay, let me not write the right side. It will bias me. So minus 2 plus 6 is 4 minus 4 lambda equal over 1 minus lambda. Let's take 4 common out of this. 4 1 minus lambda over 1 minus lambda, and voila, we got it, what we wanted. Just left with 4, which we wanted. We have shown this. Let's see what is the b part. And here is the b part. Given also L and M are perpendicular, so they not only are intersecting, they are 90 degree to each other. All right, this is the new thing, and we just assume that this was x, y, and z. All right, so find the values of a and b. When two lines are perpendicular to each other, two vectors are perpendicular to each other, their dot product is 0. Dot product of vectors. So in this vector equation, this part which is after lambda and this is after mu, these are the vector parts of the vector equation. So let me write that dot product equal to 0. So they are 2i minus j minus k dot ai plus bj plus k equal to 0. So dot product. In dot product, we just multiply the coefficients of I, j, and k. So 2 times a is 2a, minus 1 times b is minus b, minus 1 times 1 is minus 1, equal to 0. This is our equation. Now already we had one equation which we proved earlier, which was 2b minus a, this one, 2b minus a equal to 4. So we will write here 2b minus a, so plus, equal to 4, so minus 4. I just rearrange the question, this equation, okay? I wrote it like this so that I can cancel out something. Nope. So let's do this a, I'll bring it to the right side. So 2b minus 4 is equal to a. That's what we can write. And substitute that in the first equation. 2 times a is now 2b minus 4. I'm using substitution. Minus b minus 1 equal to 0. 4b minus 8 minus b minus 1 equal to 0. 4b minus b is 3b. Minus 8 minus 1 is minus 9 equal to 0. 3b is 9. Divide both sides by 3. So we get b equal to 3. And to find a, we can use this one. A is 2b minus 4. 2 times 3 is 6 minus 4 is 2. So we got a equal to 2. What is the next part? See, when a and b have these values, okay, the values were a is 2, b is 3. Find the position vector of intersection of L and M. Position vector. And position vector is another format of coordinates. So let me use one of the coordinates I assumed in the initial first part of the question. These were the equations, and now we need to find the value of lambda and mu. Let's go to the first equation, which is this. So minus 1 plus 2 lambda equal to 5 plus a is 2. 5 plus 2 mu, right? So can we get one equation out of this? Yes. 2 lambda minus 2 mu equal to 5 plus 1. 2 lambda minus 2 mu equal to 6. Can I divide all of them by 2 so that it becomes a simpler equation? It becomes lambda minus u equal to 3. So lambda equal to u plus 3. Right? Now, let's use this second equation to get rid of lambda. So 3 minus lambda was equal to 4 plus b. b is 3 mu. Now lambda is mu plus 3, so I will write 3 minus mu plus 3 equal to 4 plus 3 mu. So let's write here 3 minus mu minus 3 equal to 4 plus 3 mu. So 3 and 3 cancel out. Let's bring this 3 mu to the left side. Minus mu minus 3 mu equal to 4. Minus 4 mu equal to 4. So mu is minus 1 according to this. Then what is lambda? Lambda was mu plus 3. Lambda equal to minus 1 plus 3, which is equal to 2. So we got the value of lambda as well as mu. Let's confirm with z coordinate if it is correct. I'm 100% sure it will be right, but still let's confirm if our calculations are correct. 4 minus lambda is 2 equal to 3 plus mu, 3 plus minus 1. So 2 is equal to 2. See, we are perfectly correct. So, but the question was not to find lambda and mu. Question was to find the position vector of M. So let's use lambda, these equations to get the coordinates. X equal to minus 1 plus 2 lambda. Lambda is 2. So it becomes 4 minus 1, 3. y equals to 3 minus lambda, which is 2, 1. What about z? 4 minus lambda, 2. So 3, 1, 2 are the coordinates of M. Let me show you which one. Here. 3, 1, 2. So 3, 1, 2 are converted to position vectors. So position vector of M, which is OM, will be 3i plus j plus 2k. That is the position vector of M. Question number 10. The complex number minus 1 plus square root 7i is denoted by u. Okay, it is given that u is a root of this polynomial, given polynomial, where k is a real constant. Find the value of constant. So if a root exists for a polynomial, just substitute x by that root and you'll get a zero remainder. That's what it means. We have done this in one of the previous questions, so let's do it. So our polynomial is 2, and in place of x we will write now 1 minus 1 plus square root 7i cube plus 3 minus 1 plus square root 7i square plus 14 minus 1 plus square root 7i plus k equal to 0. And when we expand these, I'm sure i's will get cancelled out. That's why we will get a value of k, because k is a real constant. I'm sure they will cancel out. So let's do it one by one. We can use our calculator to do this calculation of cube, or you can use this formula: a plus b cube equal to a cube plus b cube plus 3a square b plus 3ab square. Okay, but I'm using my calculator to get this and shorten the process. If I cube this, I get 20 minus 4 square root 7i plus 3. If I square this, I get minus 6 minus 2 square root 7i. Then we have 14 times minus 1 plus square root 7i plus k, and that is equal to 0. Alright, so this will be how much? 40 minus 8 square root 7i minus 18 minus 6 square root 7i plus, rather not plus, minus 14 plus 14 square root 7i plus k equal to 0. And we should first look at i's because they must cancel out. 14 minus 6 minus 8, yes, they are cancelling out. Minus 6 minus 8, minus 6 minus 8, yeah, minus 14 plus 14, cancel out. 14 minus 18 is 22. 22 minus 14 is just 8. 8 plus k equal to 0, and finally it gives us k equal to minus 8. Okay, B part says find the other two roots. That's the B part. I have not copied here, but find other two roots. Of course, it's a cubic polynomial. It will have two more roots. But whenever we have one of the roots as a complex number, its conjugate will be the second root. So second root is straight away known to us. Second root will be the conjugate of minus 1 plus 7i. It will be minus 7 square root 7i. That's the second already. The challenge is to find the third root. For third root, we must convert these roots into factors first. So factors, because of this conjugate, will be x minus, that's how we do it, and minus 1 minus square root 7 I. And we already had one complex number u. For that, the factor will be minus 1 plus square root 7i. So these are the two factors already. We will get the result of these two. So let's open the brackets first. X plus 1 plus square root 7i multiplied by x plus 1 minus square root 7i. So we know another identity, which is a square minus b square equal to a plus b, a minus b, right? If I consider this thing as a and this thing as b, so it becomes a plus b, a minus b, so it will be a square minus b square. So let's open this up. X square plus 2x plus 1, that is the expansion of this, minus 7 complete and minus 1, that will be the expansion of this one, which is plus 7. So what do we get? X square plus 2x plus 8. This is the multiplication of the two factors we already know, which are this and this. Okay, so why I'm doing this, let me explain to you. If I want the factors of, say, 30, okay, and I know that 2 and 5 are two factors, right? So what do? I multiply 2 times 5, which is 10, and divide 30 by this 10, we get the third factor, which is 3, right? So that's what I did. I've multiplied these two, I got their multiplication, and now I will divide the polynomial I had with this particular result. So x square plus 2x plus 8 divides the polynomial we had, which was 2x cube plus 3x square plus 14x, and we got minus 8, k equal to minus 8. So this is what we'll do with long division now. So 2x cube and x square, I need 2x to multiply so that I get 2x cube here. Then 2x times 2x is 4x square. 8 times 2x is 16x. I subtract them, this cancels out, minus x square minus 2x, and then we have minus 8 already, and yeah, we're getting it minus x square minus 2x minus 8 when we write minus 1 in the quotient, and we are not left with anything. It is a perfect factor. So your third root, we got, this is a factor, okay? They're asking about the roots. So to convert this into root, make it equal to 0. 2x is equal to 1 and x is equal to half. This is the third root. We had second root already, this one. One root was given in the question, and this is the third one. Part C of the same question. On an Argand diagram, sketch the locus of a point representing the complex number z minus u equal to 2. That's what we have to show. So let me try to draw it here. Okay. Now, my scale will not be that perfect, but let's try to be as good as possible. So we need z minus u. U was minus 1 plus square root 7 I. The locus has to be 2. That means the distance of z from this has to be perfectly 2. And when can we have perfectly 2 distance from a particular point? With a circle. So first let's focus on minus 1 plus 7i. So minus 1, suppose it is here, and square root 7 is about 2.64. So 2.64 will be somewhere here. This is the center of the circle. From this particular point, which is u, we need to have a circle with radius 2 units. So it will be something like this here, and it has to go up. Okay, let me make it a little thinner so that it is better to see. All right, this is done. On an Argand diagram, we have shown z minus u equal to 2. Okay, that's it. Now, next part says determine the greatest value of argument z. I'm talking about part D. Argument z for the point on this locus, this circle. Locus is the circle now, giving your answer in radians. So greatest value for argument z. Just like it was z minus u basically, here it has to be z minus something, and because there is nothing here, we can write z minus 0. So 0 becomes our reference point from where we will draw the angle. So for that, let me change the color and show you that 0 origin is the working place, and this is your half line from here, and we need a greatest angle from origin with the locus, this circle. Is this the greatest? No. Bigger, bigger, even bigger, more bigger, 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 and this is the greatest when this orange line is a tangent to the circle on the left side, the left lower side. This is the greatest uh, argument we can have. So to get the proper one, let's connect the center with the point where it is a tangent. We know that the tangent and radius always make a 90-degree angle. So this angle is 90 degree. Additionally, let's add this line to the center also. Okay, so now we are ready with a right angle triangle. How about this? We know this is 2 because the radius of the circle is 2, right? We can find the modulus of u. So let's find modulus of u. U is minus 1 plus square root 7. So modulus is found this way, minus 1 square plus square root 7 square, which will be how much? 1 plus 7, 8. Square root 8. This is square root 8. And now our job is this is greatest argument, and this line is giving us the greatest argument, which is this, right? In this triangle we have just formed, can I find this somehow? This one, this angle. Yes, it's a right angle triangle. I can, and then I can find the argument of u, which is this. I will add both of them and I'll get my greatest argument of z on the locus. All right, so let's find this. Let's call this angle alpha, and we'll call this one as beta, which is the model argument of u. All right, so first let's find alpha. In alpha we have hypotenuse and opposite, so sine we can use. Sine alpha will be opposite over hypotenuse. So alpha will be sine inverse 2 over square root 8, and it is 1 over square root 2 actually. So pi over 4. So we got alpha as pi over 4. Now we need to know beta, which is modulus, not modulus, argument of u. So argument of u, and I don't want to spoil this drawing, so I will draw it separate now as a rough drawing. So suppose this is u and this angle we want, right? But for that we can find this triangle and find this angle, right? And because we know this is pi up to this levels, we'll subtract this angle and we'll get the argument of u. So let's find this angle, because we know this is square root 7, yeah, and this is 1. The imaginary part is square root 7 and real part is 1. So we can use tan theta in this case. So let's use tan theta. Let's call this one theta. Tan theta equal to opposite over adjacent. So theta is tan inverse square root 7, which will be 1.21. Yes, 1.21. And beta, which was the argument of u, will be pi minus 1.21. We'll subtract this angle from pi, so we'll get the one we wanted. Okay, let's keep it like this. Now finally they're saying the greatest value of argument z will be greatest value of argument z on the locus will be alpha plus beta. Alpha we got as pi by 4. Beta we just got pi minus 1.21. And in radians, if I put this in my calculator, I get 2.71699 which we can round off to 2.72 radians, and that's the answer.